everyone. Welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco CCNA for exam 200-301. We're continuing on with our networking components, and we're going to look at routers and switches. And he's back with more. Mr. Ronnie Wong, how are you?
I am doing well, Vaughn. Thank you again for joining me as we continue on taking a look at our different networking components. And Vaughn, we are jumping into the realm of routers and switches today. We want to make sure that we focus specifically on the idea of the roles and the function of both of these. Now, compared to what we were talking about in the previous episode where we took a look at an overall topology, I kind of tried to group these things logically to where most of us are going to encounter them. So routers and switches, they seem to go directly together. So Vaughn, that's why I wanted to group them that way.
Yeah, I always feel like they seem to have almost like overlapping roles, but they also have very specific roles. But I think with the advancement, sometimes we kind of combine them together.
Right.
Is that an accurate statement?
Yeah, to a point, Vaughn. The very fact is most of the time we don't think about either one today. We just think about the idea of connecting. So we don't really separate the functions too much anymore. But yes, you do need to know about them, and you do need to know that they do serve specific functions. And as we go through our CCNA, we'll be spending a bit of time, of course, in understanding how to configure and as well as verify and troubleshoot routers a little bit, as well as the same thing with switches. We'll be talking about configuring, verifying, and troubleshooting switches as well. But Vaughn, at this point, we just want to make sure that we can identify the idea of the roles and the functions here clearly as we actually move forward on not only in the exam, but in the real world. You want to know where these devices actually work, as well as how they actually function so that you can have an understanding, even if this is your first job, at what their role is going to be and at least a basic knowledge in their functionality. So Vaughn, that is what we're doing. We're just taking a look at those different devices.
All right. So based on your diagram that we were just looking at in the previous episode, the router was like the first place when we were coming down from the internet. So should we start there?
Yes, so let's go ahead and start with talking about the idea of routers. Now, I brought up a different diagram at this point because we're zooming in is what we're doing. And this particular diagram, at least for us here at IT Pro TV, this is from our practice labs, our lab provider partner that they have. And this is their entire topology that we actually do end up using throughout this show and a certain portion of the show. Some things we'll actually be using a different lab environment that I'll actually produce on my own. But at this point, Vaughn, this helps us in a couple of different ways when we start talking about the idea of routers. So Vaughn, right up here at the top of the screen, okay, I have what represents the idea of the ISP, the Internet Service Providers. You can see ISP1 as well as ISP2 over here. So that represents essentially the edge of my network going out into, well, somebody else's network is what it does. And when we connect in that way, we normally put routers. So here are the ones that are actually highlighted in the way that it appears on the diagram. The one that's labeled NY Edge 1 and NY Edge 2, those are going to be considered my edge routers going out to the internet. Okay. Now, Vaughn, that's not the only type of connection that actually leads out to the internet. Sometimes, though, we actually have different other routers that can connect us into, well, other types of service providers that are out there. What we call our WAN, right? The idea of our wide area network connections. And those may actually be connecting to many different types of wide area types of network access. And those are private networks that are not really the internet connection. So Vaughn, over on the left-hand side of my diagram, right down here, we can see one called NY-WAN1. And NY-WAN1, you can also see that this one has a connection out to an older type of what we call frame relay WAN connection. That's another type of service provider connection, as well as over here to, it looks like a Newark WAN 1. So this is maybe a branch office connection. That's a direct point-to-point connection over here that we can also have available to us. Now, Vaughn, in this type of diagram then, what we're seeing here is essentially the role of the router. Notice it is providing us essentially what WAN connectivity, okay? NY Edge 1, NY Edge 2, essentially the device in between our ISPs and of course our interior network. Over here on the left-hand side, NY-WAN 1, providing us again the perimeter or the border between the frame relay as well as this point-to-point type of connection on Newark WAN 1 over here on the left-hand side. But everything else internally, Vaughn, that's going to actually represent my LAN connection inside. So NY Core 1, NY Core 2, as well as NY Access 1, and all those devices, that is going to be internally in my network too. So Vaughn, at the very basics in terms of just regular roles, okay, it provides for us WAN, WAN connectivity is what it does, okay? Now, Vaughn, what we want to talk about, at least briefly at this point, because we'll get into this much more in depth later on, is how in the world does it do that, okay? Well, the term actually isn't found in the name itself, Vaughn, in which we actually talk about the idea of routing, okay? So Vaughn, when we start talking about in the realm of routing, routers, of course, then they can actually have routes on them that allow us, if we're actually internal on the network, such as we are actually the P-Lab Cisco 01 here, and I need to go out through this ISP connection, okay? Or do I need to get over here into London WAN 1 that's actually across this frame relay? So Vaughn, when I actually send data out that says, hey, it's actually supposed to go out through ISP 1, I send it into my network here, into the switches, and then it hits these routers, and on the routers themselves, it will look into its routing table, and it will find a route that says, you're to go out this interface right here, okay, GI0/1, and then out ISP1, and then it can do that, okay? So Vaughn, that's how it can actually be done when we start talking about the idea of routing.
So I always think of routers, they're almost like air traffic controllers.
Mhm.
You know, they're the ones that sit up in the tower and look at all the different runways and people coming in, people coming out, and decide, okay, well, you need to go to London, so
Right.
you're going to go out on the
Runway 9. Yep.
runway 9. I started saying tracks. I'm like, wait, what are those things called? Yeah, runways. I'm
Yeah.
not sure if that's exactly how air traffic control works, but that's what in my mind.
Right.
That's what
Sure.
it makes me think
Yeah.
of. And
No,
how
that's
I
a
can
great
kind of equate
analogy.
it for me.
Yeah, that's actually a great analogy to use to help us out. But that's what we have to do. Now, Vaughn, the key here, though, is even though we now know that they function by routing, right? And we understand that idea, and Vaughn's analogy works perfectly fine here. Essentially, it has to make a decision, okay? So Vaughn, just like using the air traffic controller, says the air traffic controller is the one that says, all right, here it is. Here's this airplane coming out, okay? And it needs to go out to London, and it actually is going to take runway 9. It decides that, and it relays that, of course, to where it's actually going to go and do that. Now, Vaughn, we have to talk about how in the world the routes get in there. In other words, the routers themselves and how they actually do this in terms of routing, okay? Well, there's two basic ways that they do this. One, Vaughn, is that we can configure the router what we call using static routing. Static routing, Vaughn, means that you actually configure the route directly on the router. You tell it, if you're going to be here and you need to go here, here's what you're going to do. You're going to take any data that's actually heading to this network, and you're going to either send it out an exiting interface, or you're going to send it towards some next hop router is what you're going to do. So Vaughn, we can configure something like that to do that. So let me show you an example of what I'm talking about right here, and this will help us out. Now, Vaughn, I went ahead and pre-configured this because we're not really getting into the idea of the configuration. But when we take a look at this, Vaughn, this is essentially a representation of the routing table. And when I talk about what I said is that we could actually do this directly ourselves. So this is me statically or administratively issuing a route. So I configured this particular route here that says, hey, I want to go to 172.16.16.0. And if I do so, I need to actually send it towards 192.168.16.3. Okay, so that is me configuring that route and telling it what to do. Now, Vaughn, this type of routing happens, does happen today. Especially, we know exactly where that route is going to go and doesn't have to actually worry about anything else. We can do the static routing and actually manually configure that.
But it sounds like, of course, you kind of want almost like the devices to think for you.
Yeah.
The devices to go ahead and say, this is the quickest point, or this is the most effective. It's kind of like Google Maps, right? Where it says like, well, I think you should take this route.
Right.
But I know that this roundabout's no fun to go around, so I always take the other route, even though it's 2 minutes slower. I'm determining that I'm going that way. So that's more of a manual route versus I'm going to automatically find the route that's best for you.
Yeah. So Vaughn, when we start talking about it in that way, right? So routers, they can say, hey, I can accept this route that Vaughn has typed in or that I've typed in, or the routers can learn routes from other routers. Okay. And the way it does that is through using some type of dynamic routing protocol is what ends up happening. So this is where we configure the routers to run different routing protocols, and as long as the routers can actually use those same protocols, then it will work. So let me show you what I'm talking about here on my screen just for a moment. So Vaughn, over here on NY Edge 1, even though we've configured a static route for it, okay, and over here on NY Edge 2, we haven't even taken a look at that one. But what we can do is we can configure them to run the same routing protocol, essentially talking and speaking the same language. This is how you're going to learn routes from me, and this is how I'm going to learn routes from you. So we can configure a basic routing protocol or even an advanced routing protocol. We're just going to do a basic one at this point, which I've already done. But what that actually allows them to do then, Vaughn, is whatever routes that was actually now learned by the routing protocol on NY Edge 1, if the other one has a connection to it, so this one has multiple connections, as you can see, going across from NY Edge 1 to NY Edge 2. If this is running the same routing protocol and it has a network that's actually in common with it, well, it too can learn about routes that it doesn't know about from NY Edge 1, okay? So that means that it's not statically configured, but these two routers can begin to exchange and learn routes from each other. So Vaughn, when we take a look at something like this, let me go to NY Edge 2. Okay. And now when we take a look at this routing table, Vaughn, I can see something right here. The R here represents a routing protocol, an older routing protocol called RIP. Okay. And this is what it actually does for us, a routing information protocol. Okay. RIP, it actually says, hey, look, I've learned about this particular route from, well, RIP. So that means anybody else that's speaking RIP that's actually connected, I can learn about their routes that may not be directly connected here. So Vaughn, what it actually ended up finding out is that there's a route to 172.18.0.0, and it learned it in two different directions, going out of this interface as well as going out of this interface too. So it actually presented both of them, and when it actually took a look, it actually took a look at, well, this information right here, okay? And the information says it's equal distant to 172.18.0.0. And instead of getting rid of one, it says you can take either one and it will get you there. Just like Vaughn's example of the idea of the Google Maps or whatever maps that you choose to use, it can show you multiple routes and say, hey, there's really not a bit of difference between these. Let me just show you both of them and you choose which one you want to do, but at that particular point in time. Now, routers are a little bit more unusual in this way. If it's actually equal distant in that sense, it'll actually load balance between both. It will send one packet this way, one packet the other way. But overall, though, Vaughn, that's what the routers do. So, Vaughn, remember that idea of the functionality here, right? The role itself provides for us really WAN connectivity between different networks. But then the functionality, though, is based on routing, which we can manually configure or statically configure routes, or we can tell it to use some type of dynamic routing protocol. And we're going to talk about really just one in our new CCNA, but there's other ones out there, just like the one that I just showed you, RIP. There's also EIGRP, there's OSPF, there's even more, BGP. They're all out there and available for you to be able to use. But for those of you that are going on to more advanced certification levels, such as CCNP, you actually get more into the other ones. We'll just be taking a look, at least in this one, about using OSPF is what we'll actually be doing. That's going to be our focus.